Okay, good morning. Welcome to
FamilyMath921.
FamilyMath921. So today we're going to talk about modular arithmetic.
Alright.
And we're going to look at something pretty neat called, first we're going to look at something called Wilson's theorem. That p minus 1 factorial is congruent to, that's the symbol for congruent, to minus 1 mod p. Okay? So, what's a prime number that you know? Maybe one that's not too big.
3.
3, okay. So what would this say for 3?
Well, you have 3, so p minus 1 is 2.
Okay.
2 factorial is just 2.
2 factorial, which is just 2.
And that's congruent, well, 2 is 2 mod 3, or you can say it's negative 1.
Negative 1.
Mod 3.
Mod 3. Okay, so is 2 factorial? Same as minus 1 mod 3?
It is.
Okay. And what does that mean, minus 1 mod 3?
So it's 1 less than a multiple of 3.
Okay, cool. Let's check it for another one.
7, how about?
Okay. Alright, so what does the statement say for 7?
Well, it says...
Oops, sorry about that.
7 minus 1 factorial, which is
Messed
6.
it up. Okay, so 6 factorial is congruent to minus 1
Mod 7.
mod 7. Okay.
So 6 factorial is 720.
Alright, so 720. Is this congruent to minus 1 mod 7?
Well, 721 would be a multiple of 7. So 700 we know is a multiple of 7. And 21 we know is a multiple of 7. So yes, this indeed works.
Alright, yay. So I can erase the question mark. It is.
Equal to mod 1. Or negative 1 mod 7.
Okay. And this is going to be, this is how the book Illustrated Theory of Numbers starts talking about something called quadratic reciprocity. And I thought you might find some of the ideas in quadratic reciprocity interesting. But this is just sort of a kind of a fun fact. Can you think of why this might be true? So we have 6 times 5 times 4 times 3 times 2 times 1 is congruent to minus 1 mod 7. Can you see what might be causing this to be true? When I take this product, I get minus 1.
Well, let's see.
You can write a little bit if you like.
Well, maybe if we look at all of the numbers. Mod 7. Well, we have 1, 2, 3, 4, 5. Let's see. Well, I guess maybe one reason is you don't have a 7 in here because 7 is a prime number.
Okay.
You wouldn't have any 7s.
All right. What would happen if you had a 7?
It would automatically be 0 mod 7.
Okay, nice. Okay, that's a great observation. So we don't have any 7s, so we know we're not going to get 0.
All right. What could we try to do? Well, I guess for 6 is minus 1 mod 7, and then I just multiply it by the other numbers.
Okay. So 6 actually just becomes minus 1.
6 becomes minus 1.
What does 5 become?
5 becomes negative 2.
Okay.
4 would become negative 3, and so on. But we couldn't really do this all the way down, because if we did, we would get a positive number. So if we just keep going, then we'll stop at 1 times 1.
Alright.
And this is all, this sum or this product here is always going to be an even number of numbers except for 2.
Mm-hmm.
And let's see. So this becomes negative 5 factorial.
Yeah.
120.
Yeah, it's interesting. It's a tricky. It's not obvious. Although if we think about it a little bit more, maybe we'll do that later on. We'll think about it a little bit more. But you get a -1. You can leave these 3, 2 as 1 is the same as 3, 2, and 1. Then we're going to get a -3 times 3, a -2 times 2, and a -1 times 1. So we get -1 minus 1 squared times -2 squared times -3 squared. So we get some squares.
Alright.
And it turns out that those all work out to be -1. But we'll see. We'll see
Alright.
a little bit more about this later on. Okay, so next I want to talk about are squares in prime, with primes. Okay?